Hello everybody, today I'm going to analyze one simple problem, this one. We are given a binary string as in 1 second all occurrences of 0, 1 are simultaneously replaced with 1, 0. The process repeats until no occurrences of 0, 1 exist. Return the number of seconds needed to complete this process. Well, this problem can be solved in many ways, but let's consider the most obvious and straightforward one, brute first approach. Later we will consider more efficient. So, before we start, let's convert our original string into the array of characters. For brute first approach, we have to call two methods, and the first method is to validate that we have reached the final state. Let's call it sorted. The implementation of this method is kind of obvious. We have to iterate through all characters, comparing the two neighboring ones, looking for the pattern 0, 1. If found, this pattern means we do not have a solution yet, because it's easy to see that the potential final string can only contain pairs 1, 1 or 0, 0 or 1, 0. So if the pattern 0, 1 is found, we can safely interrupt the process and return false. Otherwise, we will return true. Next, we have to implement the transformation procedure. The implementation is straightforward as well. First, we have to introduce the variable counter to count the number of transformations or number of iterations. Next, we are introducing a loop, and the condition of exit from this loop, the string must be sorted. On each iteration, we are creating a copy of current string, a copy of current array of characters, and next we have to iterate through all characters, and if we find the pattern 0, 1, we have to switch these characters. It's easy to see that the time complexity of this algorithm is going to be big O of n squared, because we have to iterate through all characters, and if the length of string is n, we have to iterate through all characters. This gives us big O of n, and we potentially have to iterate to repeat this procedure n times, and the final evaluation for the time complexity is big O of n squared. As for the space complexity, because we have to make a copy of string on each iteration, we have to reserve the space in the size of array of length n. So this gives us the space complexity big O of n. Let's test this solution. Okay, it works. Now we have to add one more check for the age case. Basically, if the size of string is 0 or 1, this means we do not have to perform any transformations and we can return 0 immediately as an answer. Let's check all cases. Okay, it works, excellent. Now, can we get a better solution? Yes, we can. This is a visualization of transformations for the following random string 1, 0, 0, 1, 1, and so on. I marked with yellow color the path of ones on their way to their final place, and you can literally see the dynamics of their moves. It's easy to see that the answer to the question asked in this problem is the length of the rightmost path, which shows the trajectory of the rightmost char1 to its final place. It's easy to see that the length of path is increased due to some delays in moves, and these delays are correlating with the continuous blocks of ones, and this gives us the idea how to build a super efficient algorithm to crack this problem. Basically, first we will start from converting the original string into the chars array, and we will introduce one more variable to hold the size of this array. Next, we have to check the age in cases. If the size of string is 0 or 1, we can return 0 in this case. And next, we have to find the rightmost one in our string. We are introducing a pointer, let's call it last, and we are iterating from the end of string towards the beginning. In this case, we will exit the loop once we find the one. If we do not find any ones, we can return 0 as the answer. Now the variable last contains the position of the rightmost one in our binary string. Next, we have to calculate the number of zeros to the left of this rightmost one. This will give us the lower boundary for the answer, because all these zeros at each point of transformation will be switched with the rightmost one, and yeah, this will give us the lower boundary. The implementation of this part is quite straightforward as well. Okay, now we have the lower boundary, And if our binary string is consistent from ones, basically if it's just one continuous block of ones, in this case we can return 0 as well as an answer. And now here is the main loop to calculate the excess, the delays in both paths. Basically we are iterating through the string starting from index 0 till index last, and each time we meet the continuous blocks of ones, we are increasing the variable excess, which will hold the basically the current state of current size of queue of delay. And if we are going through 0 character, we are decreasing this excess. Obviously this value cannot be negative, so we have to cut off in case of negative values. We can do this like this. It's easy to see that the space complexity of this approach is constant. We do not need any buffers for initial string, and also the time complexity is much better because we have to iterate through all characters in our binary string just once. And this gives us the time complexity big O of n, which is theoretically best possible solution. Also we have to add the processing of one edge case if our binary string is starting from the continuous blocks of ones. And that's it. Let's run this solution. Okay, it works. We can run all cases. As you can see, its performance is off the charts. Thank you, that's all for today.